Hi, future doctors. Welcome to the next class. We were discussing about variation of resistance with the length, area, mass. Today we'll see variation of resistance with temperature. If we increase the temperature, what happens to the resistance? In first year, we came to know coefficient of linear expansion L2 minus L1 by L1 into T2 minus T1. So from this, we'll write L2 minus L1 equal to L1 alpha T2 minus T1. So same like this. So we are going to get here variation of resistance with temperature. Alpha is equal to RT minus R naught by R naught into T minus 0. L2 means final length at temperature T2. L1 means initial length at temperature T1. So at 0 degrees Celsius, R naught is the resistance of the conductor. Let us assume. Next, if you raise its temperature from 0 to T degrees Celsius, its temperature is RT, we are assuming. Same like this, we are writing. Here, alpha is coefficient of linear expansion. Here, alpha is coefficient of resistance, temperature coefficient of resistance, we are going to say. So, if you rearrange this equation, RT minus R naught is equal to R naught alpha T you will get. So, RT is equal to R naught plus R naught into alpha T. So, if you write finally RT is equal to R naught into 1 plus alpha. So, this equation will be helpful. Resistance of conductor at particular temperature is equal to resistance of the conductor at 0 degrees Celsius 1 plus alpha. So if you know resistance of the conductor at 0 degrees Celsius, then you can find the resistance at particular temperature. So then only you have to use this equation. But if they give resistance at particular temperature, then you have to do like this. At a T1 temperature, resistance is R1. At a T2 temperature, resistance of the conductor is R2. Then how we are going to write this equation? So at a T1, R1 means R1 is equal to R naught into 1 plus alpha T1 because temperature is T1. So this is completed. Now for this, R2 is equal to R naught into 1 plus alpha T2. So if you divide these two equations, R1 by R2 is equal to 1 plus alpha T1 by 1 plus alpha T2. So now you can cross multiply this. So once if you are cross multiplying this, R1 into 1 plus alpha T2, R2 into 1 plus alpha T2. If you expand this, R1 plus R1 alpha T2, R2 plus R2 alpha T1. So you can rearrange this R1 alpha T2 minus R2 alpha T1 equal to R2 minus alpha. If you are taking alpha common, R1 T2 minus R2 T1 equal to R2 minus alpha. So final equation is alpha is equal to R2 minus R1 by R1 T2 minus R2 T1. This is the final equation for alpha if you know R1, R2 at particular temperatures. Now you understood this equation you have to use if you know resistance of the conductor at 0 degrees Celsius. If they give resistance at 30 degrees Celsius, resistance they will give 100 ohm. At 40 degrees Celsius, what is the resistance if they ask? They will give alpha for you. Then you have to use this equation. You cannot use this equation because here R naught is resistance at 0 degrees Celsius. Same like this, you will get resistivity also. Where you got RT, there you will get rho T. So RT is equal to R naught into 1 plus alpha T. Same like that, rho T is equal to rho naught into 1 plus alpha. So for conductors, this is concept of theory. For conductors, if you increase temperature, resistance will increase. For semiconductors, for semiconductors, if you increase temperature, resistance will decrease. For alloys, so for alloys, so its resistance is going to be constant. So therefore, whenever we are writing this formula, R2 minus R1. So alpha is equal to R2 minus R1 by V rho. Okay, R2 is increasing, resistance is increasing for conductors means alpha is positive. Resistance is decreasing means R2 value less compared to R1. Then alpha is negative for semiconductors. For alloys, alpha remains constant or zero, they are going to say. Because resistance minus resistance will become zero. Nichrome, aluminum, so nichrome, chromium, and all these will be calling alloys we are going to say. So this is about how variation of resistance with temperature. This is main formula for you. So by using this formula also they may ask the questions for you. I hope you people understood. You can try to solve the problems with this concept now. Thank you.